This is R.D. Sharma Solution Class 12 Chapter 18 Maxima and Minima VSAQ. Very small answer question we are taking. Write necessary condition for point x equals to c to be an extreme point of the function fx. Now there are certain things you need to understand: necessary condition, necessary, sufficient condition, necessary and sufficient condition. So if you draw a function or imagine a function, what is the extreme point? These extreme points are nothing but the critical points. The critical points are where the slope is going to be 0. Wherever the slope is going to be 0, those are the extreme points or the critical points. So you have fx, this one, you can just differentiate this f dash x and then equate it to 0. This f dash equals to 0 is the necessary condition. But since x equals to c, for the extreme point of the function fx at x equals to c, just replace x by c. That is going to be f dash c, which is equal to 0. So this f dash c, this is nothing but dy by dx. Again, extreme point or the critical points, whenever we have certain function, we differentiate it, we equate it to 0, try to find out those points where the function slope is 0, and then those are the critical point. Then we check for the minima and maxima for all these points. That is what we generally do in maxima and minima and the differentiation. So the line which is parallel to the x-axis is actually the line which is having dy by dx equals to 0, that is m or tan theta equal to 0. So this is the line which you need to write. Write sufficient condition for a point x equals to c to be the point of local maximum. So as I just suggested that we have the necessary condition. Now we have the sufficient condition as well. So critical point or the extreme point, CP or EP you can call it. Now the necessary condition was the differentiation and then putting it to 0. You have the function fx, you differentiated it, you call it as f dash x, that is dy by dx, equals to 0, and at x equals to c, which is given in the question, f dash c equals to 0 is the necessary condition. But this question is asking about the sufficient conditions. So this is one of the condition, but it has to accompany one more condition, and that condition will include the necessary condition. What is the necessary condition? How do you prove that certain thing or certain expression or certain value is showing the maxima or minima? Remember, when we used to get negative, we say maxima. When we used to get positive, we say minima. So we do the double differentiation. That is, if you have dy by dx, which is f dash x, d2y by dx2 is f double dash x. And at x equals to c, this becomes f dash c, this becomes f double dash c. So this f double dash c, as I said, f dash double dash c, if it is less than 0, this f double dash c or double differentiation is less than 0, we say it is maximum, greater than 0, it is minimum. These are the necessary and sufficient condition. So you just have to add one more line to the question number 1. If fx attains the local minimum at x equals to c, then write the values of f dash c and f double dash c. Now we have the function fx, original function, y equals to fx. dy by dx is f dash x, single differentiation, first derivative. At x equals to c, what do? It's f dash c, first differentiation. So in order to find out the critical point or the extreme point, then we say f dash x equals to 0 at a certain point, f dash c equals to 0. Now the local minimum, what is the local minimum? F double dash c, in minimum of course is related to the greater than 0 sign. Maximum is related to the less than 0 sign. So when we double differentiate it, at x equals to c, if it is greater than 0, it is minimum. This question is all about minimum, but I'm just saying that if the question would have been local maxima, then this condition you have written, f double dash c is less than 0. So in terms of words, you are going to write like this: f dash c greater than 0, less than 0. This is the difference between previous question and this question. Write the minimum value of fx is equal to x plus 1 by x is greater than 0. Now first thing is the fx, which is x plus 1 by x. Now the minimum value, for that you need to have the differentiation. F dash x, 1 minus 1 by x square. This is called the equation number 1. Local minimum, local maximum, f dash x equals to 0. We call it finding of the extreme point or critical point. 1 minus 1 by x square is equal to 0. 1 by x square equals to 0, x square equals to 1, x will be equal to plus minus 1. Now are we going to take both the values? No. Because x is greater than 0, we cannot take x less than 0, x equals, so we need to take x equals to plus 1 or 1. Next thing, for minimum, we have to find out the double differentiation. So the single derivative has to be converted into double differentiation. 1 minus 1 by x square, the differentiation is 2 by x cube. I'll just change it. There is a slight change here. It's not 1 by x cube, because the differentiation of 1 minus 1 by x square is not going to be 1 by x cube. It's going to be, if you take this x square in the numerator, it will be x raised minus 2. Minus 2 will come in front, minus 2, and minus 1 is already there, so it will be 2 in the numerator, and then n minus 1, so it will be minus 3, so it goes down. So 2 by x cube, 2 by x cube. What is x? X is equal to 1. So 2 by 1 cube, it is going to be 2. So x equals to 1 is the point, critical point or extreme point, and the value of the function at x equals to 1 is the 1 plus 1 by 1, that is 1 plus 1, 2. This is 2. This is your answer. Now in the words, you are going to write it like this. The same question now, we have to find out the maximum value. Now you are aware what you have to do. Previously, in the previous question, we found x equals to plus minus 1. Remember? Same thing is going to come here, and from there the turn will be different. So first differentiation is f dash x, which is 1 minus 1 by x square. F dash x is equal to 0, so 1 minus 1 by x square is equal to 0. X will be equal to plus minus 1. So x is greater than 0, that means you cannot, no, it's not x greater than 0. Oh, there is a slight mistake in the question. X is less than 0. X is less than 0, because the previous question and this question will be similar. Okay, so there is a slight change here. I'm just apologizing for that. X is less than 0. So x is less than 0, we cannot take x equal to plus 1, we have to take x equals to negative 1 for that. So f double dash x now, it is the double differentiation we have already done, it is 2 by x cube. Now keep that x equals to negative 1 and you are going to get the negative value here. Negative signifies that you are talking about the maximum value. In double differentiation, we are not much worried about the value, we are more worried about the sign which is going to be coming. So f negative 1 is 1 minus 1 by, this is 1 plus 1. See, 1, if you differentiate this, see, there is two things which are going to be changed here. So when you get it here, you just place negative 1 here. So negative 1 plus 1 by negative 1. So negative 1 plus negative 1 is negative 2. So this is negative 2 is the answer. Now what has happened? See, in the previous question you said, or we got 2 for the minimum. Here you got negative 2 for the maximum. So this is the water, moving uphill. That's not possible, no? It's just possible because the graph is like that. The graph can be, because we are talking about local minima and local maxima. So this is how you have to write it. Write the point where fx equals to x log x, x attains a minimum value. X attains minimum value. So this is x log base ex. So the function or the original function is x log base. This is log base e. So x log base ex is what? See, fx is equal to, this is the first one, x log base ex. F dash x is the differentiation. Let us take the differentiation. So x log x is 1 by x plus log x, differentiation of x is going to be 1. 1 plus log x, it will be, f dash x is 1 plus log x. Now the second thing is, we have to equate it to 0. When we equate it to 0, it will be 1 plus log x equals to 0. 1 plus log x equals to 0 means what? Log x is equal to minus 1. Now the base is e. E raised negative 1 is equal to x. Remember, log base a b equals to c simply means a to the power c is equal to b. So e raised to the power minus 1 is equal to x here. X is equal to 1 by e. This is your x. X is 1 by e is what you got. But you are not going to stop here, because we need to find out the minimum thing. For that minimum or maximum, we have to go for the double differentiation. And that double differentiation will keep this x equals to 1 by e value and then see what is the sign we are going to get. So y is equal to x log ex. As I am saying, double differentiation is necessary, but let me find out the value of y also. When you put x equals to 1 by e, the y value, because write the point where this question is asking about x and y point. So we are just completing this, just put x equals to 1 by e, and that is going to give you y as negative 1 by e. So x and y we got, because the coordinates are being asked. What are the points where this attains minimum value? 1 by e and negative 1 by e is the final answer. But the double dash or double differentiation is also mandatory, because minimum can be confirmed only by that. 1 plus log x differentiation is 1 by x. So x is equal to what? It's 1 by e. It's 1 by e, 1 by x. X is 1 by e. So it goes up. X is equal to e. E is a constant value. It's 2.7 something value. So it is greater than 0. Greater than 0 means you are going to get a minimum value. So this is the minimum value for you at 1 by e and negative 1 by e. Find the least value of fx equals to ax plus b by x, where all these variables are and the constants are greater than 0. A is greater than 0, b is greater than 0 and x is greater than 0. So the first is fx. Differentiate it now. I am doing the differentiation now. This is a, b by x is minus b by x square. This is the first differentiation. Next is you have to find out the local minima and local maxima. For that you need to put this equal to 0. A minus b by x square equals to 0. So a will be equal to bx square. X will be equal to x square will be equal to b by a. So x will be equal to plus minus under root b by a. So under root b by a you got, but the only thing is everything is greater than 0. X is also greater than 0, so you cannot have a negative value. So the negative value we are not going to take. We are only going to take x is equal to under root b by a. Negative under root b by a you are not going to take. Alright. So x equals to b by a under root is the value which is the value for which y has to be computed. But before that, f double dash x, we have to prove that you need a least value. So you are going to get the positive value here. F double dash x. The double differentiation is what? A is 0. So this is going to be 2b by x cube. Double differentiation. So x equals to under root b by a you have to put it here and then find out the value. So 2b by this x cube is, see, under root b by a is b by a to the power half. So when it goes cube, it's 3 by 2. b by a to the power 3 by 2. So this, you know how to solve this. You can just take these, with the negative sign in the numerator. Combine this b raised power 1 with b raised power minus 3 by 2. 1 minus 3 by 2 is of course minus 1 by 2. It will come down. A of course goes up. It's a denominator of the denominator, so it will be positive. So a raised 3 by 2. So twice a raised 3 by 2 and b raised 1 by 2 in the denominator. So this is the final differentiation, double differentiation you have got. But at what point? A is greater than 0 in the question, B is greater than 0 in the question. When they both are greater than 0, the whole equation is greater than 0, that is you are going to get a minimum value, least value. And the final thing is, because x is already under root b by a, let's find out y value for that. Y is equal to a, this is a under root b by a plus b by under root b by a, and that will be twice under root ab, x and y. So these are the final values which you can get x and y. Okay, and this is how you are going to go about it, solve it. Okay, so y and x you have to find out and write the minimum value of fx equals to x raised x to the power x. The first thing is fx is given as x raised to x, minimum value. For that we need to do differentiation and equate it to 0. So differentiation is quite clear to you how to differentiate this. This differentiation will start only when we take the log on both the sides. That's the only possibility. So we'll take log on both the sides. This will become log fx, and here when you take log, this power will come in front of log. So it will be x log x. Next thing is the proper differentiation. Differentiation with respect to x. Log fx, log anything inside log, it will be 1 by that thing. So 1 by fx, and this is f dash x. Differentiation of x log x is, and since you know it, but we will just for the sake of completion we'll do it. X, differentiation of log x is 1 by x, then log x, differentiation of x is 1. We are following the product rule. Product rule you already know. This will be 1 plus log x. You have 1 plus log x here. Now you have a fx in the denominator on the left hand side. So this f dash x will be, this fx will go up or on the right hand side. So this is x raised x, because fx is actually x raised x only. 1 plus log x is there. Next step is, in order to find out the local minima or maxima, we have to equate it. So this f dash x equals to 0, x raised x 1 plus log x equals to 0. And this 1 plus x raised x cannot be 0 because they have not told, question is not saying anything about it. But we just think that, okay, x raised x cannot be 0. If it is 0, then what is the point of fx equals to 0 minimum maximum value? It is not a constant. What do we do? 1 plus log x is only possibility it can be 0. So when we have log x equals to negative 1, when we equate it to 0, you get log x equals to negative 1. That means when we have log base a b equals to c, that simply means a power c is b. So this e raised minus 1 will be equal to x. So x is equal to 1 by e. This is x equals to 1 by e. So we need to find out the value here. Next thing is to equate it. So what is the minimum value and maximum value? The one more step is to double differentiate. We double differentiated it is f double dash x. That is x raised x, and then we have 1 plus log x. I'm just giving you an exercise. You have to double differentiate it, and once you double differentiate it, you are going to get certain value when you put x equals to 1 by e. That value, whether it is positive or negative, that will show you it is minimum or maximum. So what I'm trying to suggest here is you have to place x equals to 1 by e in the final value of double differentiation or final expression of double differentiation. So whatever is going to come, it's 1 by e minus 1. E is a constant value, it's 2.7 something. So it's greater than 0 because you can fit in the value and find it out. It will be greater than 0, and that is pointing to minimum value. So x is equal to 1 by e here. How about the minimum value and maximum value? Because x is equals to 1 by e is already there. You place it here, 1 by e to the power 1 by e. So that is your final value. This is the one value, then one way of writing it, but there are certain other ways also. What are the other ways? E raised minus 1 to the power e 1 by e. This e goes up. So this is simply negative 1 into 1 by e. So e raised minus 1 into 1 by e is e raised minus 1 by e. And this is how we prove it. So the final result is this one. The only thing which I have not completed is the double differentiation. But differentiation, if you have done already, you know how to do it. But the final thing is e raised minus 1 by. Now this one is the same question, and this is going to come in your MCQs also. Multiple choice question also it is going to come. So you just understand it very carefully. Fx is equal to x raised to power 1 by x. And since we have the power, this is only possible when we take log on both the sides. So log of fx is log of x raised 1 by x. So log a to the power b is b log a. This b comes in front. So 1 by x log x. And then the proper differentiation will commence. And how about differentiation? Differentiation is like this. We are differentiating with respect to x. Log differentiation is 1 by that thing. So 1 by fx. Differentiation of fx is f dash x. This 1 by x, log x is 1 by x, then log x like that, and 1 by x differentiation is negative 1 by x square. So let us replace this plus by negative because it is eventually negative 1 by x square. So x square is already there in the denominator. You can take this as the denominator and 1 minus log x in the numerator. But fx on the left hand side in the denominator goes on the right. So this x raised 1 by x is fx only. So which I have written right now. So f dash x is simply this equation which you see here. In order to find out the minimum and maximum, you have to equate this to 0. That is f dash x equals to 0. When you equate it to 0, what do you say? Or what do you get? X raised 1 by x into 1 minus log x by x square equals to 0. See, x raised 1 by x by x square cannot be 0 or cannot be 0 because if it is 0, then there is no point in finding out the minimum value, maximum value. So even if you take this x square above, that is in the numerator, it will be x raised 1 by x minus 2. So whatever you are getting, I'm just showing you different aspects. So these aspects just to prove that this x raised 1 by x square has nothing to do with our relationship with equating it to 0. So whatever you do it here, only 1 minus log x has the possibility of becoming 0. If log x is equals to 1, then this 1 minus log x is 0. Otherwise, all other things which you see here, x raised 1 by x square, you take it upstairs or to the numerator, it doesn't affect or it has no control on making it 0. I'm assuming that this 1 minus log x thing you understood. So just 1 minus log x equals to 0, you get 1 minus log x 0, log x equals to 1. I'm just implicating these different scenarios. This is not possible. Only 1 minus log x equals to 0 is possible. So whichever way you go. Now coming to the original discussion, which is 1 minus log x, which is equals to 0. Log x This all cannot be. Log x is equal to 1, that is e raised 1 equals to x, so x equals to e. And please assume and anticipate this question is going to come again in your multiple choice question. So x equals to e is the critical point where we need to check for maximum and minimum. For that checking of maximum minimum, we need to double differentiate it. When we double differentiate it, f double dash x, what do you get? If you double differentiate it, this x is equal to e. The final thing will be minus e raised 1 by e cube, and this is a constant. E equals to, because e has certain specific constant value. So all other things except negative cannot give you positive. These are constants only. Constant value, if it is positive, will always give you positive value. It can never give you negative value. So we got the maximum value because it is less than 0. You see the negative sign also. The final thing is the finding out the value of the function at the critical point, which is x equals to e. So we are eventually finding fe. Fe is x raised 1 by x. In place of x, just replace it by e. So e raised 1 by e is your final result or answer. Now you have to put certain effort in the double differentiation because it is going to take a lot of time. It would take at least 4 to 5 minutes to differentiate this. And since there are so many things involved, it may lead to some problem, but I have total assurance in you that you will be able to do it. This is the final answer for you. Now let me tell you, this question, very small answer question, these are not, because they are not small questions. They are big questions. Double differentiation, as I just reiterated, it will take a long time. So VSAQ means it need to be solved before 2 minutes. Write the maximum value of fx is equal to log x by x if it exists. Now we will see later if it exists or not, but the first thing is that the original steps which we need to follow. Fx is equal to log x by x. So we'll differentiate it f dash x. When we do the single differentiation, x, I'm following the p by q or quotient rule. You know it now. You have to take the denominator, then differentiate the numerator, then subtract. You have to take the numerator, then differentiate the denominator and square of the denominator. So now putting it to 0, when you equate it to 0, you know already why I'm not equating x square equals to 0. One logic is x square will eventually be 0 if you multiply it on the right hand side, cross multiplication. So 1 minus log x has to be 0. That is the only point we can infer from here. So log x equals to 1. What does it mean? It means e raised 1 equals to x. E raised 1 equals to x, that is x equals to e. So in the previous question also, x is equal to e. Maxima and minima will only be at this point, x equals to e. Next one is the double differentiation of double dash x. And since one level of differentiation, first derivative is already been completed, the second differentiation is your responsibility. I'm writing the final result for you just to, equate it with what you have done. Now x equals to e, when you put it here, I'm just trying to show you that you are going to get negative for sure. If you're going to get negative, that means we are trying to I upon the maximum. So negative 5 and e cube, they both are constants. So you have a negative. Negative is less than. So at x equals to e, you have to find out the value of the function, which is the maximum value, and x equals to e, that is fe, you have to x equals to e. So log e divided by base e is there, e. Please remember, if the base and the value is same inside log, it is going to be 1. Okay, I hope this is very clear to you. So log base e divided by e, this numerator becomes 1, then the denominator has e, so it's 1 by e. So it's 1 by e, that's your final answer. Okay, fe. So these are the main things. F equals to 1 by. Alright, so this is how you're going to go about it. Sometimes the students might be doing themselves, so this is the reference for you. You can check out, and you can always refer to my discussion. If you have any point of discussion, you can have it on comments. So this is all about this VSAQ. Thank you so much. Take care of yourself.